This is section 1.5, using a problem-solving plan. There are several steps to solving a problem. There are 4 that the book lists specifically. The first step is to read and understand the problem. You need to take a look at what you need to know and what you already know. The problem is going to give you some facts. I would jot these down, start to assign variables to them, and figure out what you have to find out. Then in step 2, make a plan. Figure out how you're going to solve the problem. Do you have to divide? Do you have to multiply? Do you have to add? Do you have to subtract? Is it a multi-step problem where you'll be doing all of those things? Then you want to set up the equation and solve the problem. This is actually the action part, and you may have to try a couple different things. Maybe your first plan doesn't work so well. Don't get frustrated. Try something else. When you get an answer, you want to look back and see if your answer makes sense. This is one of the most important steps that usually students leave out. You can eliminate a lot of mistakes if you just look to see if your answer is reasonable. Think about that first quiz that we took. You remember that? With the units, with feet and yards. If some of you had looked to see if your answers were reasonable, you would have seen that they weren't, and you could have corrected your mistakes. So let's look at an example. Here's a running problem. And you're talking about running in a city where the north-south blocks are 0.1 miles long and the east-west blocks are 0.15 miles long. You're going to run 2 long blocks east and a number of short blocks south, and then 2 long blocks west, and then go back to your starting point. You want to run 2 miles altogether. So you need to figure out how many short blocks are you going to run. Well, according to our plan, we look in step 1 and figure out what do we know and what do we need to know. Well, you know how long the blocks are in the city. You know the length and the width of the blocks, and you also know the total amount you want to run. They've also given you the number of some of the blocks that you want to run. Okay, so you know how many you're running in a certain direction, so that's going to help you out. Okay, but you need to know how many short blocks you have to find. We have to find how many short blocks that you're going to run. You're given the long blocks, but you need to find the short blocks. So in step 2, we're going to make a plan. Use what you know to write a verbal model. You know, that's a model with words. So if you take the distance of the short blocks times the number of short blocks, plus the distance of the long blocks times the number of long blocks, you're going to get the total distance, which is 2 miles. You take the short distance plus the long distance, and that gives you the total distance of 2 miles. Well, we can use this verbal model to write an equation. So let's solve it using this equation. I translated the verbal model into an equation. I knew that the distance of the short blocks is 0.1 and the distance of the long blocks is 0.5, and I know I ran 4 long blocks. So you can multiply the 4 times the 0.15. The number of short blocks is what we're trying to solve for, though. That's your variable. That stays as s. Both quantities added together have to equal 2. So when I have that equation, in the second step, I take 0.1s plus 0.6 and it equals 2. To solve for s, you want to isolate s on one side, so you need to remove that 0.6. Subtract 0.6 from both sides. You get 0.1s equals 1.4, or s equals 14. So you're running 14 short blocks. Remember what your variable meant. S meant the number of short blocks. Now check your answer. Does it make sense in this last step? We know that you ran 4 of the long blocks, so that's 0.6 miles. And we know you run a total of 2 miles. So the distance you run in short blocks has to be between 0.6 and 2. It can't be the total, and it can't be the other one. So our answer is logical, but is it correct? If the distance between the total and the known quantity is 1.4, that is 2 minus the 0.6, then the total distance that you run in short blocks is 1.4. Since each one is 0.1 miles, then you can figure out the number of blocks is 14. So our answer is correct. But let's try a twist on this problem now. Now that you know how to set it up, let's change something. What if in the same city I wanted to run 3 miles instead of 2? The lengths of the blocks are still the same, okay? And I've already run 2 long blocks, so how many short ones do I have to run? So go through these steps. What do you know? Well, everything's the same, but now the total is different, 3 miles. Make a plan. We're going to approach it the same way we did the first version. Okay, if we take the distance run in short blocks plus the distance run in long blocks, that will equal the total distance. Solve the problem and set up your equation. All right, so what are you going to do? You're going to write the exact same equation, but this time you're going to set it equal to 3, right? Okay, so let me see if we can do that. So we're going to take 0.1 s plus the distance of the long blocks. And what was the distance of the long blocks? Take a look back if you need to. Okay? The distance of the long blocks is 0.15. And we know that we ran 4 of those. Okay, that did not change. And that's going to be equal to 3. So why don't you pause this, solve for s, and check your answer, and see if it makes sense. The answer when you solve for s in this equation, because you're taking this 0.15 times 4 and subtracting it from 3, so you get 0.1 s equals 2.4, so s equals 24. So in this case, you're running 24 short blocks. Now the next part of this section is all about formulas. We started this in class, so this shouldn't look too foreign to you, but a formula is an equation that relates to or more quantities, and there are certain formulas you need to know. There are 4 specifically in this section that you should memorize and be very comfortable using, and they are temperature, where Celsius equals 5/9 Fahrenheit minus 32. Simple interest, where the interest equals the principal times the rate times the time. Distance traveled, where distance equals rate times time. And profit, where profit equals income minus expense. Of course, you also need to know the formulas for area. Area equals length times width, and volume. Volume equals length times width times height, as we did in the earlier sections of the chapter. You might also see a curveball for the area of a triangle. Okay, a triangle is half of a square, right? So the area of a triangle is going to be 1/2 the base times the height. If you don't remember that, 1/2 the base times the height. So let's look at some examples of how we use these. So here's temperature. Okay, you should be able to convert Fahrenheit to Celsius and Celsius to Fahrenheit. So I'm going to do an example with both so you can see how it's done. In the first example, we're going to have the Fahrenheit temperature. We're going to convert it to Celsius. So let's say it's 59 degrees Fahrenheit. Oh, excuse my spelling there. Find the Celsius temperature. So in this case, we're going to substitute 59 for F. So we get C equals 5/9 times 57 minus 32. That should be 59. I'm going to correct that right now. Okay? This should be 59. Thank you. Now, remember of order of operations here. You have to do what's in the parentheses first. Okay? Remember, our grouping symbols have to come first in order of operations. So subtract 59 minus 32 and get 27. So now we have Celsius equals 5/9 times 27. So Celsius equals 15. Remember, that's degrees, so make sure you write degrees afterwards. Don't write degrees throughout the whole problem. You're just going to get confused and think it's some kind of either variable that's an O or a 0, and in algebra that just is disaster. So make sure you write degrees at the end. Now, example 2, taking Celsius to Fahrenheit is a little bit trickier. But assume that Celsius is 25 and you want to solve for Fahrenheit. So take the same equation, but now put 25 equals 5/9 Fahrenheit minus 32. Now, in order to solve for that f, you have to eliminate that fraction that wants to be multiplied by the f in 32 first. Rather than use the distributive property, it's a lot easier to eliminate it by multiplying by the inverse. So if you multiply both sides by 9/5, remember what you do to one side of the equation, you have to do the other. You end up with 45 equals f minus 32. Then add 32 to both sides, and see, that wasn't so hard. The Fahrenheit equals 77 degrees. You should practice some of those so you get used to going between one and the other. Simple interest. Simple interest is what you get when you deposit a sum, don't touch it, and you get interest only on the initial amount. In other words, the interest doesn't build on interest. It's just on the initial amount. So the equation for simple interest is that the interest equals the principal times the rate times the time, where interest is the amount of interest earned, P is the principal, that means the initial amount you put in the bank, and R is the interest rate, that's always a decimal. T is time. You have to be careful here, though, because the time period has to agree with the time period used in the rate. In other words, if T is in years, your interest rate must be in years. If T is in months, your interest rate must be in months. You cannot use 2% per month and a time period of years and plug it into this formula. It will not work. Here's your example. You deposit $100 into a savings account earning a rate of 1% for 5 years. How much interest do you earn? So we're going to define our variables and set up our equation. In this case, P is 100, R is 0.01, and T is 5. So I equals 100 times 0.01 times 5. I equals 5. You receive $5 in interest. Distance. Distance equals rate times time, where D is distance, rate is how much distance you're traveling per unit of time, and T is time. And remember, T again must be the same unit of time you're using in your rate, just like in interest. So in example 1, you travel 5 hours at a rate of 60 miles per hour. How far did you travel? In this case, you know the time and the rate, but you want to know the distance. So D equals 5 times 60, or D equals 300. That means you traveled 300 miles. Don't forget the units there. In example 2, we'll turn this around a little bit. You need to reach your grandmother's house by morning. You have 12 hours to get there, but it's 960 miles away. How fast do you have to go to get there in time? Here you have distance and time, but not rate. So you use the same formula to solve, but solve for a different variable. We're going to have D equals R times T, or 960 equals R times 12. Divide both sides by 12 to solve for R, and get 960 divided by 12 is R, or R equals 80. That means you have to travel 80 miles an hour to reach your house in time. But think of this, is that possible? I mean, that's nice to know, but if you're driving, chances are legally you can't do that in 80 miles an hour. So if I ask you if you can get there, you better say you're going on a plane or a train, because you can't possibly drive there in that amount of time. And the last equation we're going to look at is profit. Profit is how much a business makes monetarily after deducting expenses from income. So P equals I minus E, where P is profit, I is income, and E is expense. So here's your example. You're selling St. Mary Magdalene t-shirts for $10. Each shirt costs $5 from the distributor and $2 for ink to silkscreen. You sell 25 shirts. What's your profit? Well, you have to calculate both income and expense here. So your income is how much money you have coming in. You multiply the number of shirts by how many you sell, 10 times 25. So your income is $250. And expense is your cost. Each shirt costs you $7 to make, and you sold 25. So 7 times 25 is $175. Your profit, therefore, is the difference between the income and expense. Remember, difference is subtraction. So it's 250 minus 175 equals $75.